we're going to go through what K-maps are, and we're going to go through an exam question on K-maps. So what exactly are K-maps? We can see from this textbook extract that K-maps are basically a way to help simplify complex logic circuits and expressions so it has the least number of gates and the least number of inputs. So let's start the exam question. This is the first part of the exam question, and it requires you to write the algebraic expression, the Boolean algebraic expression for this logic circuit. So the way we would do this is to first look at the gates at the leftmost. So we can see we first have a not P and a Q nor R. So this would be the first part of our logic expression. It would be Q nor R in a bracket. The brackets are really important to show which steps come first. Then this would go into an OR gate with the not P, and at the end, outside the bracket, we would have it going into an AND gate with R. And it's also important to remember that we use the symbols, so it's a plus sign for OR and a dot for and a dash above for NOT. So this would be our final answer. We can see we have Q OR R, and this has a NOT on top of it, showing that it's a NOR gate. This obviously goes into an OR gate with NOT P. You can see the bar on top. And this finally goes into an AND gate with the input R. So this is the second part of the question to complete the truth table. This part's pretty easy. All we have to do is go through the logic circuit with each of the inputs and write down the output for each expression so we get the final output. So we just match it for each circuit and then we get the final output for S. So this should be your final answer. This step usually happens before K-map questions because to simplify the K-map you need all of these outputs. So now moving into the actual K-map part of the question, what we do is we get this table. Sometimes we might not get it, so it's important to remember the order of this table because it's always going to be this order. It would be 0, 0, 0, 1, 1, 1, and 1, 0 in the top columns, and the rows would be 0 and 1. And then all we do is look at where we have an output as 1. So we can see over here we have an output of 1 when we have P is 0, Q is 0, and R is 1. So we match that to the K-map table. We can see 0, 0. We look at the 0, 0 column, and we look at where R has to be 1, because R is 1 over here to get 1. So we just write down a 1 there. And then our second one would be when P is 0, Q is 1, and R is 1. So we go to 0, 1 here, because that's the two inputs for this to get 1. And we'll look at the where R is 1. So we just add a 1 here. These are the only two outputs where you get where we get 1, so the rest can be filled in as zeros. Now, the next step is to draw a loop around the ones to group it together. So we just draw one loop over here, but it's also important to remember that we can group ones in a 4 like this, but we can never group diagonally or in a weird shape like that. And we can also go around. So if we had a 1 here and a 1 here, we would go around it to get it like that. We'd go around here to group the ones on either side. But usually that's the most complex it gets when you go around. We'd never get multiple ones where I can group in many different ways. So once we group it, we can now simplify the expression. So all we have to look at is these two instances where we have 1 as the output. So we can see 1 is the output when it's 0, 0 for P, and it's either 0 or 1 for Q. So Q can take either of the states. It can be either 1 or it can be 0, but P must always be 0 to get 1 as the output. And we can see here R also has to always be 1 to get 1 as the output. So because Q can take any of the states, we just don't put Q in the simplified logic circuit because it can take either of these two states. That's the rule. But when something only takes 1 of the two, cannot only take 0 or 1 in both of to get 1 as all the outputs, we write either not for if it's 0, or we just write as it is if it's 1. So we have just a normal R because it's 1, and we write not P. And when we are combining the logic circuits from here to here, we always use AND gate. So it would just be R and not P. So that would be our final answer. And now we can look through the mark scheme. So you can see here that the brackets are very important for this question. If we go back quickly, we can see here we put the brackets correctly to show which steps happen first. So that would be part A. And you need to show you're working out to get all the marks. Obviously in my case I've only shown the final answer, but you have to show you're working out here to get the marks. And also I think if you just had the final answer, they will just mark it in steps. So for each part they might give you the mark. Over here, this is pretty self-explanatory. Just we have to get the correct numbers in each of the in the truth table. And for the last part, we can see in this case the working out does matter. It even says here to draw the loops and to write a simplified logic expression. So we'd have to draw the loops on each part, and we can see that's a final answer. So we get full marks on that question.